So this is cool. Now, before anyone reads this and goes full on Young Frankenstein on it, this is research that is still in its infancy. So it's not quite at sci-fi level yet, but we are basically living in the future. Before I talk about the paper, I want to talk a little bit about how traditional 3D printers work. By traditional, I mean any that prints with things like plastic or metal. They work by stacking layers vertically on top of each other. So the extruder on a printer will print the bottom circle, and then we'll print a circle on that that's slightly smaller, and then so on and so forth until a shape emerges. Hobbyist 3D printers typically run about 5 layers per millimeter, maybe more than that, but this is how a traditional 3D printer works. What these researchers did instead was they laid neurons side to side like they were laying pencils on a table. This allowed the neurons to get sufficient oxygen and found that they could start talking to each other. They generated this bioink that allowed the neurons together to have enough structure to be able to stand still next to each other, but pliant enough so that they could communicate well and that they could get enough oxygen. And while research like this is still very young and in its infancy, the implications here are massive because we can use this 3D printed brain tissue to see how neurons interact together for different mental conditions. I cannot wait to see where this goes.